Engineering 305, example problem 3-4. This is going to be quick. It is, it's 6:10 in the evening. I'm going to try to bang this out because I got one more to do, and I told you I'd have them done by 7, so we're going to do our best. All right. The strain components at a point are sigma x equals 800, sigma epsilon x. We're in the strain chapter. Epsilon x is 800 micro. Epsilon y is minus 1,000 micro. And gamma, the shear strain, xy, is equal to a minus 600 micro. Determine the strain components, En, that's in the normal direction, Et, the tangential direction, and the shear strain in the NT plane if the XY and NT axes are oriented as shown in the figure. So you see the figure, I tucked it on the side right above my head. It is right. Let's see if I can do this. Right. Oh, no, it's right. Right. Oh, no, I'm still working. I don't know where it is. It's hidden. It's oriented in the picture shown. You can see that the n-axis is 30 degrees below the x-axis. That makes theta equal to minus 30. And so now you know the way I work. I've got my data. It's all right there. It's all right there. So all I need to do to solve this, to get the strains, the N, the T, the eta, and the shear NT, is to start plugging it into equations. Well, fortunately, I've got the equations ready to go. So I can start chunking in the strain in the N direction is equal to the strain in the X direction times cosine squared theta plus the strain in the Y direction, sine squared theta, plus shear NT sine theta cosine theta. All right. I can start plugging in values. They're all listed there. And when I start plugging in the values, I get something like 800 cosine squared of minus 30 plus EY minus 1,000 sine squared of minus 30 plus gamma minus 600 times sine of minus 30 cosine of minus 30. There you go. And if I calculate, oh, you know what? Yeah, so I wrote that out, but you need to see that. Something's going on here. My equation, I only get to use half of my page. So there you go. I got to remember that. That's the edge of my page. All right, so if I do that and I calculate that out, I get 610 micro. So that's that. Now, I want to do this. I want to draw their coordinate system. There's my X, there's my Y. Here's their N, and here's their T. So this was minus 30. To get to the T-axis, I got to plop in a plus 60. All right? So this data is all good. I'm just going to roll that down here, and then we're going to keep going. I'm going to put the equation back up because I'm really doing, while I'm doing the strain in the T direction, that is really, it's not now 30, it's now positive 60. And I'm just going to repeat the process. So that's the strain in the X direction times cosine squared of 60 plus the strain in the Y direction sine squared 60. And I'm running out of space. I didn't realize it. Plus gamma NT sine 60 cosine 60. What did I make? What did I mix up? Well, that looks pretty good. That looks pretty good. And if I calculate that out, oh, I don't want that. I want that equals a negative 810 micro. Yeah, there you go. A negative 810. I'll even let you see my answer. There you go. And so then lastly, and you know, just keep scrolling this up. Just keep scrolling this up. We'll put the formulas back up there. Oh, we'll use this one. Gamma in the NT direction. Sorry. Gamma in the NT direction. I lost my hold on a sec. My screen jumped and anyway, I lost my equation. Gamma in the NT direction. I'm going to use the bottom equation. So that's negative the shear in the shear. Sorry, it's not the shear. It's the normal strain in the x direction minus the normal strain in the y direction times sine of 2 theta plus the shear strain in the xy times cosine of 2 theta. And that just fits on there. And then I can substitute in minus the strain in the x. Let me get rid of that. There you go. Minus the strain in the x. The strain in the x is 800 minus a negative 1,000 sine of 2 times 60 plus the shear. Oh, I don't want to write shear strain. I want to actually put the value in, which is a minus 600 times cosine of 2 times 60, or I could have put just 120 because I can do that math. Oh man, I got to shrink that because my big ugly head's in the way. There you go. And when I calculate that out, gamma NT is equal to 1260 micro. And I guess I should put radians up there. Maybe not. I don't know. I mean, radians are dimensionless, so if you put it or not, it's okay, but it's not required. All right. All right, that was my book, passing in front, because I'm using the book all the time. That was all I had to do for that problem. Just those 3 steps. So I should grab. I can't see my rainbow pen. I have to hold on. There you go, rainbow pen, and I get that answer and epsilon t and epsilon n. There's my rainbow, and if you like the sparkles, we got sparkles for you too. All right. I hope you're doing well. See you tomorrow.